Yeah, this question says that there's a compound 1,3-dimethyl benzene. 1,3-dimethyl benzene is used to manufacture something called musky. Now we have to identify the reagents and conditions needed for each and every step. There are 3 steps. Before we do this work, before you actually attend this question, we will try to get the basic knowledge. Look at the first compound, 1,3-dimethyl benzene. In 1,3-dimethyl benzene, for the better understanding, I will write CH3 here. That's a CH3 group. On this side also, there's a CH3 group. If you try to locate these 2 places in the second compound, the product, here CH3, here CH3, and this part has been added. What is this part? Here also we have CH3. This is CH3. This is CH3. And here we have a carbon atom. It's an alkyl group. When you attach an alkyl group into a benzene ring, we use aluminum chloride catalyst and heat also. Aluminum chloride catalyst and heat. And this compound, the group which has been attached to benzene ring, should be taken in the form of a chloride. And the chlorine must be attached to the carbon atom, which gets attached to the benzene ring. So this should be the compound which has reacted with 1,3-dimethyl benzene to produce the product in the step 1. Okay. This is a compound that has reacted with 1,3-dimethyl benzene at the presence of aluminum chloride to give this. And we go to step 2. In the step 2, what happens? Let's see. The CH3 is there as it is. The CH3 is also there as it is. And this part also hasn't changed. But another group has been added. Let's analyze what this group is, the attached group. It is CH3. This is carbon. Children, in the step 1, the name of the reaction is alkylation. It means addition of an alkyl group. The step 2 is acylation. What is the difference between alkylation and acylation? In alkylation, an alkyl group is getting attached. In acylation, I'll do the structure over here a bit above. In acylation, there should be carbon, double bond oxygen, and there should be an R group. And to this carbonyl group, there should be a chlorine added. For this also, we have to have AlCl3 and heat. It's not much of a big difficult thing. In the first one, this chlorine goes out and this carbon atom is getting attached to the benzene ring. In the step 2 also, this chlorine goes out and this carbon is going to get attached to the benzene ring. Let us see what is happening in step 3. In step 3, the 2 CH3s are not changed. The alkyl group which was attached in the step 1 is not changed. And the acyl group which has been added in step 2 is also available. Now we have NO2 here, NO2 here. NO2 group has been added. What do you think should react over here with this product of step 2 to make the product of step 3. For this, we have to use concentrated to add NO2, concentrated HNO3, concentrated H2SO4, and temperature of 50 to 55 degrees Celsius. The only byproduct of step 2 is HCl. In step 2, it is HCl. Yeah. Suggest reagent that was used in this step. What reagent was used? Reagent I have given over here. This is the reagent which was used. Because it's just one line given to you, I'll write the structure R C O C L. This is the reagent used in step 2. Suggest the type of reaction that is occurring during both step 2 and step 3. In step 2 and step 3. Take the type of reaction. Actually, even in the step 1, substitution occurs. If a reaction happens on the benzene ring, most of the time it is electrophilic substitution. This is a typical reaction type of benzene, electrophilic substitution. State the reagents and conditions needed for step 3. Step 3. Conditions needed are concentrated HNO3, concentrated H2SO4 at a temperature of 50 to 55 degrees Celsius. You can write this over here. I can explain to you the step 1, taking some other reagents, so you will get the idea clearly. If you want to add a CH3 group, just let me draw addition of CH3. Actually, these are substitution reactions. If this is benzene ring having CH3, an alkyl group has been added. Always remember, the reagent you are going to use should be CH3. On this side, there should be chlorine. If you use aluminum chloride catalyst and heat, the CH3 is going to get attached. And then this CH3Cl has one chlorine. This chlorine goes out with the hydrogen which is coming from the carbon atom to which the CH3 is getting attached. Actually, there are 6 hydrogen atoms in the benzene ring. You know that from the basics, there are 6 hydrogen atoms. When the reaction occurs, 1 hydrogen goes out and only 5 hydrogen remains. For every substitute group getting into a benzene ring, 1 hydrogen goes out. There are no hydrogen over here. So the removal, let's say this is the hydrogen which is going out. This hydrogen plus this chlorine gives you HCl. This is one reaction. I'll take another example now. I'll copy the same thing and I'll do modification to it. This is just to say that these reactions are very much similar. Now I want to add something else. What is it? Probably, let me take another halogenoalkane. This time the halogenoalkane I'm going to use, take it like this: chlorine, CH3, one more CH3 here. Just assume one hydrogen is here, one chlorine is here. This CH3 is not the substance which has been attached to it now. The group which is attached to this contains one hydrogen. The carbon has one hydrogen, one CH3, another CH3. And this part is coming from this halogenoalkane substance where the chlorine gets detached. It is here. And from benzene also the hydrogen goes out. It is HCl over here. Always remember, when you want to attach an alkyl group, we have to take a halogenoalkane and then you allow the reaction. This is about alkylation. If I go to the next type of reaction, it is acylation. There's no difference between alkylation and acylation when you take the reaction mechanism into consideration. So I will remove these products from these two alkylation reactions and go to an acylation reaction. In an acylation reaction, this is just to tell you that these reactions are very simple. I can most of them several examples. I can just explain using these compounds which I just cut and paste. This time I'm going to remove this hydrogen. And from the second compound also, you can remove this. And I want to add CO. This time I will take CH2 and CH3. How are we going to convert this? You can see how simple this is. You don't have to do much of a big thing. You see the place where this group is attached to the benzene ring. It is this place. All what you do is take this part of the molecule to figure out the reactant, which I have done here, and adjust the chlorine over here. This is a reaction. Now you may ask the difference between alkylation and acylation. I said earlier, it was just an alkyl group, something like CH3. CH3 getting added to benzene ring is an alkylation reaction. However, if a group which has a carbon-carbon double bond and also an R group here, if you add a group like this, it is called acylation. So this is acylation. However, you are not asked to, you will not be asked to differentiate between alkylation and acylation, but then your knowledge should be there. Here also we use AlCl3. Then what will be produced? As in the earlier case, the chlorine atom of this reagent and the hydrogen, they will get together. These two substances will get together and go out as an HCl. So here we have HCl. This is a byproduct. Let us see what is going to get attached over here in this acylation. You can write anything. CH3. Maybe here you have a cyclic part, and here we have hydrogen. Now, what is the reagent you are going to use? Again, See the simplicity of this. The reagent which is reacting over here has a chlorine atom attached to the carbon, which is making a bond with the benzene ring in this manner. AlCO3. It's a very, very simple reaction. Of course, heat is needed. I didn't write this earlier. Heat. This is how acylation reaction occurs. Now, if you want me to show this also, it's easy if you make sure small notes in this manner to understand how exactly the reaction is happening. So HCl should be here. See this HCl. I can do a similar thing for the second one also, but not very necessary. However, just to complete it, HCl is produced as a byproduct. See how molecules join together, and during this connecting of two parts of two molecules, how a small molecule goes out. Now, if someone tells they are condensation reaction, yeah, we can say they are condensation reaction because when two molecules react together, making a bigger substance, a small molecule goes out. By definition, condensation reaction. So this is a summary of alkylation and acylation reactions, which are touched in the first question in our lesson. Fourth one. Suggested structures of the two products form when A is reacted with alkaline aqueous iodine. Alkaline aqueous iodine. What is this reaction with alkaline aqueous iodine? It's a special reaction. We call it iodoform test. Iodoform test. What are the substances which give positive results for iodoform test? The following compounds give positive test for iodoform reaction. A second. Following compounds give positive test for iodoform reactions. What are the compounds? There are 3-4 compounds. You should know this by heart. First one is ethanol. Ethanol is one, and methyl ketones. And then secondary methyl alcohol. And only one more compound I can give, particularly ethanol. Ethanol is a primary alcohol. Ethanol is the only primary alcohol which gives positive test for iodoform test. Now, what is important about this ethanol? What is similar about this ethanol? Methyl ketone, secondary methyl alcohol, and ethanol. It is a primary alcohol, but if you use this iodoform test. Ethanol, I can write CH3, CO, methyl ketone means there should be a methyl group attached to the carbonyl group, and afterwards there can be any alkyl group. Secondary methyl alcohol means again there should be an a secondary methyl alcohol has CH3 group attached to alpha carbon. Alpha carbon is a carbon to which the OH group is attached. Secondary means there can be another R group over there, and there should be hydrogen over here. And then ethanol is CH3, CH2, OH. Here we have a CH3 group attached to the functional group, CH3 group attached to functional group, CH3 group attached next to the functional group, CH3 group is attached next to the functional group. During these reactions, the circle CH3 come out of the molecule and it produces CHI3. This is a yellow substance. This yellow substance is identified as iodoform. But the name of this is triiodomethane. Triiodomethane. And then the other part of the molecule can go to here H, CO, O minus Na plus sodium salt. The second compound, it also produces CHI3, and the other part is going to go to a carboxylic acid, RCO. If it's a carboxylic acid, I must write OH, but because sodium hydroxide is there in the medium, you get Na plus. That gives you the conditions needed. We call it alkaline iodine solution. We can write sodium hydroxide, iodine, heat is also needed. These are the reaction conditions and reagents needed for all these reactions. And what about here? Here also this CH3 part goes out as CHI3. And the other part comes as RCO, O minus, Na plus. This one also produces a similar thing. Only one carbon remains when iodoform, well, CH3 part goes out. CHI3. Plus H, CO, O minus, Na plus. Yellow precipitate. So if you heat any of these compounds containing methyl group, the functional group, attached to the functional group actually, attached to the carbon atom in the functional group, we get a yellow precipitate. So by looking at this, we say it has characteristic precipitation as well. This is a very, very important information regarding iodoform test and the compounds which give iodoform test positively. So the question has two structures to be drawn. What structures? Suggested structures of the two products found when A is reacted with alkaline aqueous iodine. You can write over here, alkaline iodine, alkaline aqueous iodine means, yeah, we can definitely, as soon as you see this condition, we can see that, okay, this is iodoform test. Fine. Now we go to compound A. Compound A is this. If this compound reacts in iodoform condition, what will happen? There should be a CH3 group attached to a functional group, the way how I explained earlier. I can see a CH3 group which is going to give a yellow precipitate. It's over here. CH3 is there. What will happen? This whole part goes out. No, this part goes out. I'm sorry. This part goes out as CHI3. And the other part is a huge molecule, but I will draw the structure in small font over here. Benzene ring. This NO2 on either side is here, one NO2. When you write NO2 on the left-hand side, please write the NO2 letters in the reverse sequence. And at the bottom, we have that big alkyl group attached. On the left-hand side, one CH3 group. On the right-hand side, another CH3 group. And over here, we get the carboxylate functional area O minus Na plus. Okay, this CH3 part breaks off, producing CHI3. And to this one, to this carbonyl group, you get oxygen. Actually, OH comes, but because the medium is sodium hydroxide, alkaline, the carboxylic acid part goes to sodium carboxylate. So this is one product formed in the reaction. This is the other product. These are the two compounds, please take down.